routing, we have covered the basics of router, basics of hardware, we covered OSPF, PIGRP, and also in the last class we have covered, what did we cover in the last class? We covered how we do network address translation, right? So any questions on network address translation? I also sent you a packet tracer file, right, which has a complete configuration in it. What I'm actually trying to tell you is, save this first, file, open, any questions on your last lab, network address translation? If you see here, I added a public server and I also have a laptop. You see here, Kavya?
Yes, sir.
Hello, is there? Yeah.
Yes, I'm
And
there.
Kishore, so see, I'm sending packets here. What is the port address here? 192.168.1.2, right? This is a previous class, NAT. And here it is, 21.21.2. I'm sending packets from here to here. Something is happening. Maybe it's the routers are powering up. Let us see. Let's power on the router. Okay. I powered up. Right. When I powered up, what's the problem? Okay, you see here, the packets are moving up, right? So let's see what's happening next. Then go here. So the port address should be 192.168.1.2, destination should be 21.21.2, right?
Yeah.
So let's see the source address here. What's the source address? 21.21.21.2, destination IP 120.168.2, very good. But we are doing outside NAT here. So let's see the packet IP address it looks like, what it looks like outside NAT. So capture as soon as we do the outside NAT from here to here. So ideally it should, come on, okay. So ideally, this packet, as soon as it gets done with outside NAT, it will take an address translation and it will get the IP address from the NAT pool, right? 192.168.2 should be some other IP address. So let's see what it becomes. You see this? What happened as soon as it hits the router 1 and to the Vlan device? The IP address of 192.168.1.2 became 171.168.16.10. Basically what happened here is, it took the network address translation. And the IP address, the reason it took 16.10 because, if you see here, we have defined the NAT pool. In this NAT pool, the first address of the very first address of the pool is 121.68.16.10. So we assign 192.168.1.2 with address translation. As soon as the ICMP packet left this router 1 from this outside interface, it took a different address. This is a practical example of how network address translation took place. So this service server, when the packet comes to the receiving end, to the WAN IP address, it will have a source address of a WAN IP address. So when the server, public server, replies to that WAN IP address, it gets to this router, as you see here. It gets to this router. As soon as it gets this router, it detects that IP address belongs to the pool, and it gives a reverse network address translation back to the piloted. You should also observe that I have associated the new subnet. If I go here and do the show run, if you do here, if I do the show run here, you should observe it that I have added a new subnet, right? 192.1.2. I have added the subnet and I have added the subnet to take an IP address from an output. See, access list 1 has two subnets, 16.88.168.1. So as soon as it enters the network address translation outside source 2, it will take the IP address translation from the pool. Yeah. For example, if I do access list 1 and add the server subnet 21.21.0 onto the access list 1, it will also get translated, right? Will it or will not? Yeah. It will be. You can try. We can open it and see packet by packet capture and observe how the source and destination addresses change as soon as the network address translation is done. So just CDP packets now. The packet has been reached, so they're just saying CDP packets just to make sure they're all aligned. Okay? So moving back to our class today, what's our class today? It's about switching. Okay? So there is a particular way to arrange your network. So when we say arrange your network, we're basically talking about the design. So whenever you design a network, the primary aim should be how redundant and how reliable the network will stand. That means when I say redundant and reliable, redundant depends on the design factor, right? Whereas reliability depends on how well we are networking or how well we are engineering the network. But considering the design factor, there is a way you arrange your network. And there is a way you arrange your network in a particular fashion that helps you with the scalability. That means in the future, if you add more and more devices to the network, that network should be able to withstand the growing traffic, and also it should be scalable. It should be able to answer or deliver the services to the end device in a reliable way, right? So in order to do that, we should break the design or break the setup of the network devices into 3 layers. So this is one good way Cisco always suggests you to design is to have a core layer on the very top, which provides the fastest connection between the distribution points. And if you go down, you will have a distribution layer that provides policy-based connectivity between end user LANs. Okay? When I say policy-based connectivity between end user LANs, I mean local area network. For example, you look at your basic simple network here, okay? So in this network, you can see a kind of tree kind of structure, okay? Let me take the screenshot of this. You can see that the design is being kind of distributed, right? So you look like, this looks like a tree top. And this looks like a tree top, or a tree trunk or tree branch. And this here looks like the edge of the branch, right? If you observe further closely, the core switches are layer 3 switches. There is a difference between layer 3 switch and layer 2 switch, which we will learn shortly. So this is nothing but access layer, okay? Sorry, this is nothing but core layer. Why I am calling it core? Because this is where you define all your layer 3 VLANs and layer 3 routing, and also this is where you connect your entire network to a WAN router and to the ISP, okay? Or ISP or MPLS router. Okay. So we discussed how we route between the routers, how we route to the static, how we route to the Vlan. We also discussed how we redistribute static routes. We also discussed about something about how we do redistribution between OSPF, EXEC, and BGP. But here, before the story enters the router, there is a lot of story that happens within the local area network. Okay, this is all local area network. But it is not as simple as it sounds. We have so many users. Here we only have 5 or 10 pieces, but in fact we will have 5,000 pieces. So to have a proper scalability and distribute the traffic evenly, we will design a redundant core. So if you look at here, this is the primary core and this is secondary core. Just imagine if this device goes down, you still have secondary core having switches running to all the end devices, right? So you have this link, you have this link. So when you see the redundant links going through, what does it suggest? It suggests that its scalability is high, and also it is very redundant. So even though this device goes down for any reason, you still have a redundant link going to the switch layer, distribution layer. The distribution layer, you can distribute your network to local areas. This is of course a big local area, but from core to distribution, distribution to access, we have 3 different hierarchies, right? So difference between the distribution and the access is, you can see here, the access switch doesn't have so much redundancy. This switch has redundancy to both the distribution switch. But this switch does not. This switch only has one uplink. And this switch of course again have redundancy, but this switch does not. It will only have one uplink. So the distribution and the access is, the access areas are somewhat remotely located to the rest of the network. So it is not possible to run a redundant link to all the access switches from distribution. There is no way access switch should connect directly to the core, because core is securely configured inside the data center. From the core you will run cables to the distribution. So the distributions are set up such a way that they are accessible to all the access layer switches. So this might be building 1, this might be building 2, this might be building 3, this might be building 4, this might be building 5. But the access switch can be somewhere located that is close to both building 1 and 2, and sometimes close to building 3 and 4 and 5. But we should make sure distributions are both located somewhere in the close proximity where you can connect the cables. Otherwise you will fail to add up a redundancy. So talking further about access layers, you can see that all doesn't have redundancy. So in case, just imagine if this device goes down, this access layer, this region goes out of network, this region goes out of the network. So for example, if building 1 is a very important building, you will make sure your distribution both switches you can run cable to 1. If you imagine this pi is not somewhat important, you will not waste too much fiber running from each switch to the access layer. Distribution layer. The cable fiber, you cannot simply run like 2-3 cables for redundancy anywhere, because cable is also very expensive. And also, just imagine, if you have too many connections, too many broadcast terms, too many loops. That is where spanning tree comes to prevent the loops. See, this switch, if you get a traffic, if you get a ping request from here, this goes from this link to switch and it goes to all the outer links except from the link where the traffic came from. Right? You send broadcast to all the ports. So this switch has one broadcast term, 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 this switch has one broadcast term. And coming to the distribution, you have one very big broadcast term. Come to this switch, you have very big broadcast term. And come to the core, now you have very big broadcast term on the core. Now, imagine at this interface of the router, you have a huge mammoth broadcast term. So you should also consider looping into the effect. So whenever you engineer the switching ports and also VLAN, you should make sure you have your spanning tree parameters set all correct. Okay? I know it might be too heavy to understand the concept of VLAN and span tree right away, but you should consider one important fact that more the switches, more the connection, more the broadcast term. Right? So many broadcasts. So many broadcasts. And this broadcast term ends up with the interface of Vlan router. This question about network design. So, the access layer is entry point for the user workstations and servers, which is this one. You have switches, servers, and also connect servers here, right? So, if this is a server room, you must have multiple redundant rooms because server room will do a lot of business, right? Server where we configure our website, where we configure our database servers, where we configure our important business transactions. The server rooms should always run with redundancy. So, access layer functions also include layer to layer filtering. Layer 2 switches are used in the access layer. As I explained earlier, layer 3 configuration is entirely done on the port switches. In the worst case, you will define a layer 3 VLAN on distribution. Basically, you will trunk the VLANs that are configured on the core and then allow them on the interfaces. We will discuss shortly in a while how we configure VLAN trunking and also how we configure access VLAN. So that is what I was explaining. You should be able to scalable. The scalability is an important factor. So if you have multi-layer campus-like design, you should always make sure more the traffic builds. You should be always able to entertain the growing traffic and the growing network. The design should not break apart. I already requested you all to learn about different kind of hardware switches, right? So the one that you are looking at here, popular access switches are 1900 series, 2800 series, 2900 series. So these all are layer 2 switches. First three ones. Catalyst 400 series, 500 series is where you build mostly distribution switches and core switches always come like layer 3 switches. In the layer 3 switches, you can configure IP interface and configure an IP address. You can configure routing also sometimes. Obviously, you can configure routing all the time. But we don't prefer to put too many routes on layer 3 because it's doing the job of both switch and router. So your primary concentration on how you configure the layer 3 VLANs on the core router. The distribution layer, as I explained, they fall in between the core and the access layer. They should be able to isolate network problems. So distribution, if you have a problem with a network reaching to the work group, where you look for, you don't look in the core, right? You first try to troubleshoot at the access layer on this link, right? Because this access switch is connected with this both distribution switches on its primary link. So you will first troubleshoot on these links. If you don't find anything wrong here, you will then go to the core and see how the layer 3 IP address is doing. Is it down or up? If it is down, all the end devices will be down, right? First you will do a physical layer 2 inspection. And after doing layer 2 inspection, if everything looks good, you will go up to the core and figure it out whether the layer 2 IP address is up and countable. And then when we come in here and see if the VLAN has a proper layer 3 address, you will see that story in a while, how we configure layer 3 VLANs and everything. So all I discussed. So distribution layers which operate both layer 2 and layer 3 are the OSMO. They are like a kind of mix-up between core and access layers. So there are very famous distribution switches, 2800 series, 500 family and 600 family, 6000 series 5. So 6000 series is a very famous layer 3 core switch, and also you can use it in distribution because it is also very functional distribution. Nowadays in the data center, you will see a lot of Nexus switches, okay? So do that for homework, what are Nexus switches, what are Catalyst switches, and what are standard family switches. The core layer is a very high-speed switching backbone, right? That we discussed. Because it just connects to what? The core layer, it connects to the Vlan network. So the core layer is very, very important. It's like the backbone of your network. If you break that core, you will lose your entire site access point. So switching is very tricky. So I explained just before 2 slides ago, fabric switches mostly compare with standard switches. We also have 8500 switch high-end switches and IGX for 8500 switches, but 6500 switches are most popular. We also have one more popular variety called VSS. But for our class, for our CCNA, we will only be highlighting standard switches. Now, we already discussed about how we usually configure switch and how the hardware works, right, in our introduction class. The hardware of the switch comprises of CPU, RAM, and the operating system. We all can explain where we store the configuration file. We store it in where the startup configuration is stored, and where the iOS configuration is stored. We all discussed it, right? You should be able to answer it. You all know how to access to the directory inside the switch, how to find any RAM, how to find a file system, right? Yes, further. So, directory all file. Okay. See how many directories you have. You have flash. You have flash where you put your iOS or operating system, Cisco iOS for this example. In the flash you have Cisco iOS stored here, right? And what are the other files we have? And VRAM is where we store. What are these stored there? So startup configuration files, where do you store them? File is not present, right? Now you saw in startup, why we failed to see startup earlier? Because I did not save the file yet. So once I save my running configuration, it will end up in VRAM and stored there. So we all discussed about what the designation of NVRAM and also the regular flash and how each directory is important when it comes to storing each type of file. For example, the iOS is always stored in the flash. The flash can be of various types. It can be external flash or internal flash. You can sometimes plug in your thumb drive and during the ROM on mode, you can always boot up booting it from the flash. And you can see here the switches, the 2950 catalyst switch here, the one that you are looking at. You can observe this is not one big switch. They are actually stack of switches. One upon each, one upon each, one upon each. They're all basically layer 2 ports. They probably cannot be configured with a layer 3 activator. So each switch hardware has their own status indicator, which is the LED indicator. If the LED is in amber, it means the port is trying to communicate with the upstream port and trying to come up. What if the port is red? It means it is down. It is configured, but it is down. What if the port is showing no signal on its LED? Then that means, you know what that means? That port is admin down. We should all be able to identify the difference in LED status. We also discussed about power on self test. What happens when you power on the switch, right? And also, you see that we have three LED stages in the initial power on cell step to happen. We also discussed how you connect a switch to your PC console using a roller cable and using the STM, and you also use a hyperterminal. And I also showed you how to set up the baud rate, how to set up the bits, 96 bits per second. It's all we discussed in introduction class. Also discussed about help command and trying to put a question mark, right? For example, if I don't know show, run, I don't know the command, I will put a question mark, right? Const t, for example, interface, okay, what's the next part of this command? I'll put a question mark. There's so many interfaces, loop back, or you can put the tunnel, so many things. If I help command, you all by now enable and configure mode. So show versions for running, show interface status, show controller. See, we will talk about the controller and all in the future, but when we discuss about Vlan. But for now, just keep your attention to show version, show running configuration, show interface state. Okay, so we also discussed about the difference between configuring line console password and also user level password, right? This is when you connect the console, right? When you connect your PC to the console, it will ask for password if at all you have configured line console and password. And same applies to the login password. So if you can allow 5 users to connect simultaneously. VTY 0 to 4 means 0, 1, 2, 3, 4. So you can have 4 users connected to the VTY. And then also you can set up a password to the line VTY. So show user, you have 0 user. First user is idle, that is me. If you line VTY 0 to 4, you can, how many users you can have? 5 users. So run VTY 0 to 5. Now also put line configure. VTY 5 to 15 also configure T. Line. Okay, login. You can use local. So then you'll find, right? You found how many extra users now? 10 more users. So you can total 20 users can log in now simultaneously. So I'm going to skip spanning tree protocol for now because before I explain you the spanning tree, you should be able to understand what is a VLAN and how the VLAN is configured. What's the difference between layer 2 VLAN, layer 3 VLAN, static VLAN, and also how access VLAN is configured, how trunking is configured. VLAN is like 5-hour class, but I have to average it to 1 hour, okay? So be patient, it's going to be a little tricky, it's going to be easy though, because I'm going to show up every single thing that I explained here, okay? So the switches, why we need to configure VLAN on a switch? We discussed in the earlier classes that switch has one good tendency to block one thing. What is that? If you have 10 users connecting to the switch, it can block the traffic of the conflict. CSMA, collision, carrier sense multiple access. CD, collision domain. CSMA, CD, right? The switch can break the collision domain. If there are 30 users connected to the switch, and 31 want to try to communicate at the same time using the switch as a medium, they all can, because CSMA, collision, carrier sense multiple collision domain. Carrier sense multiple access collision domain. Switch has that capability to break up the collision domain. So, how does the switch get the capability? Okay, see, take a basic switch, okay? Take a basic switch. When you do show VLAN, this is a switch freshly out of the box, okay? When you show VLAN, what are the VLANs you will find? You will find just VLAN 1. Forget about these VLANs. you just find the VLAN 1. And what you call the VLAN 1, you call it as native VLAN because all the ports come with the VLAN 1. And even if you find it, if you observe that VLAN 1 will also have spanning tree applied to it by default. Understood? Give me 1 second. So we have default VLAN set to all the ports, right? So if you configure a new VLAN, you can break up all these ports into individual ports, right? Right, Kavya, right, Kishore? So I can, okay, see Kavya here. So you see here, we have these many ports, right? So if I want to break them into break the collision domain, of course the switch take care of everything. It switch has, for example, 5 ports, 6 ports. If you connect each user, of course you will be able to send traffic and you can configure everything under one single VLAN. But what if there are multiple users, right? Multiple users with from multiple departments. For example, this port, this is connected to, for example, one team which is purely dedicated for the billing. Let's call it billing. And let's imagine there is one more team that is connected to transactions or insurance claim team. Right? Let's imagine there's one more team that is a HR. See, they don't want to have some other department share their network, which is access network, not the level 3 network, okay? Not the level 3 network. Layer 2 network with them. So what we have to do, we have to classify these users, and this user in a separate VLAN. We cannot put them all on the same VLAN, right?
Okay. Yes.
We have to configure multiple VLANs, okay? So at the end of the day, multiple VLANs you configure layer 2 VLANs. They need some kind of routing to reach the gateway and to the WAN router side. That is where you define layer 2 VLAN. So now let's discuss about layer 2 VLAN. Okay, for example, just imagine, take this guy, take this network, okay? Take this network, show IP interface, please. We have these many ports. Very good. There are so many ports. But show VLAN, have only one VLAN. And all the ports are in one VLAN. I don't want to this. I want to classify some ports into different VLANs. So configure the VLAN. For example, VLAN 3 I will say. Okay. I will name it as, what should we name it? Like example, yellow team. Oh, okay. You cannot have space in the name. So I have a show VLAN. Now I have VLAN 3. But what are the ports we assigned? We did not assign any ports to it. Okay. So what is the port which is connected to SS023? It is connected to some PC. So let us go there. Configure T. Okay. Configure T. Interface SA0x23. VLAN. Switch port. Access. VLAN 3. Right? So what I basically did is, this is the access layer. On the port, I need to access a device. So I gave it the switch port access 3. VLAN 3. So show VLAN now again. So we have one port under its name, right? Everybody following me, right? Everybody able to follow me? Now, you can also give another VLAN also. configure the VLAN 2, name it as red team. That's all fine. Okay. Show VLAN. Now we have 2 and 3, yellow team and red team. Configure the interface SA 0/24 switch port access VLAN yellow team. Sorry, VLAN 3.
VLAN 2, right?
VLAN 2. Right. So show VLAN ID. You cannot give more than one VLAN on one access port. Right? You cannot tell both billing department and HR department to share one port, right? They cannot share. It will be a conflict of interest. So now we have very good VLAN division. We classify them properly, right? VLAN 1, 2, and 3. So let's say VLAN 2 yellow team. Let us declare one more team. Configure key, interface, VLAN 4. I cannot give the VLAN number 1. Why? Because VLAN 1 is native VLAN, it's default. Name, let us call this as blue team. Oh. Sorry, cancel. Name, blue team, and VLAN ID. So, VLAN. So, blue team has no ports assigned to them, okay? Let's assign some port to the blue team, okay? Configure team, interface, SA, fast internet, port 20, switch port, what's the command? Access, VLAN. VLAN number is 4.
VLAN 4.
And ID. So, VLAN 4 is known as blue. You can also see the name here, blue team, yellow team, red team. Okay, so this guy is connected to SA 023, right? So what is SA 023?
VLAN 2.
VLAN yellow team. VLAN 3, right? So we call this guy VLAN 3 yellow guy. Yellow team, okay? So let's take one more PC. Okay? Let's connect one more PC. Okay? So we connected one more PC here. Where is it connected to? Let us take. We will connect to the port that we define, okay? So we define what are the other ports that we define?
24 and
20 and 20, okay. 20 and 20. So let us connect to this guy to which port? 20. And take one more PC. Let us take this guy and let's have connect him to which one now? 24. Okay. So now this guy is connected to 20. So what is the VLAN assigned to the port 20?
24.
Blue team. VLAN 4. Right? So VLAN 4 blue team. So this guy is obviously VLAN 2, right? In real-time scenario, VLAN 4 might have 30 pieces. VLAN 3 might have 40 pieces. VLAN 2 might have 50, 30 pieces, okay? For some reason, this port is slowing down. So let's go, what happened? Configure the interface. 0/24. No shut. Keep and clean. So, okay, very good. We have VLAN 4, VLAN 3, VLAN 2. But how to give IP address to this PC? And how you configure IP layer 3 addresses and have them ping each other, route each other, right? So we need
one question, Harsha. Let's
yeah,
suppose we said there's multiple pieces, right? So if for VLAN, if it's again a route, a switch and multiple pieces are connected, so can we make
multiple pieces can be connected to same VLAN. Yes. Okay.
So, but you said we can't use the same VLAN number to multiple.
Okay, I will show you. So VLAN ID 2. VLAN ID the red team is connected to SA04. Configure C, interface, SA0/19, switch port, access VLAN 2. Okay? So show VLAN ID 2 now connected to multiple ports. So SA0/19. I will go here and bring back here. SA0/19, right? So this PC is now connected to where? VLAN 2, right? So let the team VLAN 2, right? So now we have a very good distribution and access picture. So we have 2 users in VLAN 2 and 1 user in 4 and 3. In real world, VLAN 2 might have 50 users. They all might belong to one HR team, okay? And VLAN 4 can be blue team, right? Here red team. So red team people, if there are 50 members, you can all have them assigned to which VLAN. If they say newly joined, okay? You have hired a new guy into your company, and he was hired by red team manager. So which VLAN you will assign to his PC port? You hired a red team guy.
Okay. You will assign it to the VLAN 4.
Yeah, which VLAN you will assign? Red team guy.
4. Red team is VLAN 2.
Yeah, switch port access VLAN 2. You see, I assigning. So you will have exclusive access to the VLAN 2.
But before you said one statement that you can't release the VLAN number, so that's
VLAN ID 2. You see, you assign 2.
I can't write that statement.
You cannot, okay, I will tell you. If you have port function 0/21, say function 0/13, switch port access VLAN 2.
Okay.
Can you put one more VLAN? No, you cannot put it.
Got it.
For example, if I put this, okay. Now do show VLAN ID 2. So VLAN 2 has 3 ports. So I'm coming back again to interface SA0/13. Switch port access VLAN 4. From the same port I'm going to say, will it accept? Yeah, it will accept. But what happened to that port? You see, show VLAN ID 4. Do show VLAN ID 4. So what happened? The number 13 is now joined the VLAN 4, which is blue team. So the red team number now joined blue team. It cannot be number of this port, cannot be number of blue team and red team. Understood, right? So you cannot put 2-3 VLANs in the same access port.
Yeah, it is like an IP concept. Yes.
You cannot put 2-3 VLANs in the same port. Yeah, in fact, actually, if there are more than 2 VLANs in one access port, remember how I'm stressing access port term? I'm stressing access port because access port is an access port, trunk port is a trunk port. We will learn about trunk port in a brief moment. Access port is access port. You cannot override 2 or more VLANs in one access port. The problem is if you have a DHCP server that is trying to assign 10.21.21.3 IP address to the VLAN 23, and if the same access port is configured in VLAN 24 also, it will be confused which pool to pick. You understand what I'm saying? There will be conflict of interest configuring one access port with multiple access VLANs. Only trunk port can be configured with multiple trunks because it is not configured at access layer. It is configured at between switches. If you have a dozen VLANs here, if you have 20 VLANs here and you want to pass those VLANs into this switch, you have to trunk them on the trunk link. That we will talk about in a brief moment. Now, everyone, we configured VLAN 2, VLAN 4, VLAN 3, but remember, this is just a layer 2 VLAN. Okay? They cannot ping each other because pinging, reaching, transferring data requires IP address. When you talk about IP address, layer 3, so we configure just layer 2 VLANs, right? VLAN and name, and we're able to classify the end switch. But how do you configure VLAN 2, 3, and 4? You have to go here onto the core, because core you can configure both layer 3 and layer 2. On the core, you can configure VLAN 2, VLAN 3. For example, here I configured VLAN 2 already. So VLAN interface VLAN 2. You see here I configured VLAN 2 with IP address. Let us configure layer 3 VLAN, okay? And show VLAN, okay? When I do show VLAN, VLAN 2 is there. What is the VLAN 2 name? Configure things. VLAN 2 name identity, right? And also show IP interface brief. You will see VLAN 2 with an IP address because it's a layer 3 here. When you do go to the access switch instead of core switch and do show IP interface brief, what you find here, you will only find layer 2 VLAN with no IP address, right? So VLAN. There is no IP address assigned on interface of this VLAN because these are all still layer 2. Now, to communicate between layer 2, layer 3, layer 4, we have to configure IP address on the core. Configure T interface VLAN 3. Give me any private address. For example, 192.168.192.16.2.1. Remember the IP address we gave, 192.1. Just in case. Which is interface VLAN 3, right? So, VLAN 3. Just say network address. You configure network on anyways on the core, right? So we'll go here. This is what VLAN 3, right? This is what yellow team. Now this is red team, right? VLAN 2. Network address is .co red team. So this is what yellow team. This is VLAN 4. We have, let's see, VLAN 4 will give address. Give me some other private address. 172.168.2.0. Okay. This is yellow team. So VLAN 4 interface VLAN 4 IP address. Did I get the classification? Is it the private address? You have to tell me.
Actually, you get two yellow tags. One is the blue tag.
Okay. So VLAN 4 is blue team. We can change the names. No problem. Okay. Incomplete command 255.255.0. Now shut. And VLAN 4 is configure VLAN 4 name blue team, right? and show VLAN 4 is root, 2 is red team, where is 3? Configure VLAN 3, name, yellow. Okay, and show VLAN. So we configure 3 VLANs, but the difference between the configured VLANs on the access switch and core is, if I do show IP interface, you will find the IP address. What happened to the VLAN 4? So run interface VLAN 4, right? No IP address, interesting. Then configure properly then.
Sure.
Interface VLAN 4 IP address 172.168.2.0. Oh, okay. 172.2.0, we cannot use it. So change it to 190, change to some 10.25.25. Want some unique looking private 172.1.1.0 to bad mask again because not 192.4.5.6. Interface VLAN 4 IP address .3.4.0. We are giving a network address instead of a. You got it what I'm saying? We're giving a network address instead of a host. This will act as our gateway. 197.1.1, okay? Show IP interface brief. You should have told me that because you should always use the network address. Sorry, always use the host address, not the network address on the interface, right? Which will stand as gateway to all the network address. So see, I have defined layer 3 for each VLAN, right? So I have defined the layer 3 now. So what should I define now? I should send them on a trunk link, right? I have defined layer 3 and here. They should reach until this guy, this switch. So I have to pass some trunk from here to here, here to here, here to here. So how will I do that? So there are two VLAN, with the VLAN 2, 3, 4 network gateways configured on layer 3. So I come to the distribution switch. And I will define here again the same VLAN. Configure to VLAN 2, okay? VLAN 3, VLAN 4, right? And so VLAN. Now VLAN 2 before are added to the VLAN database on the distribution switch. Now the tricky part. How does core switch know that we define VLAN here? They don't know. The only way they will know is you have to trunk them. Trunking means, in the olden days they used to trunk call. For example, if you want to make a call from New York to San Francisco, it never used to be one direct call. Because the cable, the phone extended, maximum use it to reach, it only used to reach till Nevada. So from again Nevada, I believe Colorado. So from again Colorado, they used to trunk that call to another subscriber, and they used to join the call, and then the call is to route to the California. So they used to trunk the calls. You see, in the olden days, you might have observed in the movie that you got a trunk call. That means the other person is calling from a way far distance. The link is here also, that's the problem. The link here is not directly connected to this switch and this switch. It has a switch and there are connections. So you have to trunk them with the information. With the information, you have to trunk the information. So let's make the trunk call here. Configure the or else in this information trunk interface. SA01, SA01, okay? Interface SA0 by 1. So, how do you, we already seen how we configure the access VLAN, switch port mode access VLAN, right? So here we are going to configure switch port access. Here not the access, we are configuring switch port trunk. So switch port mode trunk. Switch port mode trunk. We also have to mention what kind of trunk. Encapsulation. So trunk. What I'm trying to look here is how do I mention the type of encapsulation method, okay? For example, we have the let's see that. Actually prepare the configuration. You should be able to select switch port mode encapsulation, okay? Why the page is not working? You see here, somewhere here we configured as a trunk. I got a slow internet. I'm trying to define the encapsulation here. When I say encapsulation, there are multiple mechanisms to explain the switch port that you are configuring it from. There are multiple, you see that switch port mode trunk, right? Here you are explaining what kind of encapsulation method here, okay? So going back on the multi-layer switch port trunk encapsulation, what kind of encapsulation is part 1Q. There is also different encapsulation which is called ISL LES, which is no longer service. It is now a legacy encapsulation, okay? So always make sure you always mention .1Q. .1Q is a protocol or 802.1 protocol that explains, that gives VLAN tagging, okay? .1Q helps VLAN tag. So example, you are allowing VLANs, right? For example here, you are allowing VLAN 2, 3 and 4 from this part of the port to this port, right? You are trunking. How does this switch know which VLAN traffic is 2, which VLAN traffic is 3, which VLAN traffic 4? How it will know which VLAN belongs to which VLAN number? .1Q tags the traffic with a VLAN number. So .1Q is a protocol. Just like various protocols, 802.1Q is what? It helps in VLAN tagging for Ethernet port communication. Understood? I already told in the introduction class to study about .1Q and VLAN tagging, okay? So now on this switch, on one end we have configured switch port trunk encapsulation, okay? Switch port trunk allows VLANs. You have to mention the VLANs 2 and 3 and 4, right? 2 and 3. And just assume 2 and 3. Oops, I forgot the VLAN 4. How do I add the VLAN now? If I do switch port trunk allowed VLAN 4, it will override the previous statement. I will show you. Show run interface. Which interface we are configuring trunk? This interface, right? SA0 by 1, right? Show run interface SA0 by 1. It will not work, but show run SA0 by 1, you see? Oh no, trunk is been overwritten by VLAN 4. Why? You see here, I also earlier configured the access port. You cannot configure interface as both access and trunk. So see here what I'm going to do. Interface SA0 by 1, no switch port mode access. So do show run. You cannot configure that both same port as a port trunk and access. You see? I have to remove this command also. Control C, configure T interface. You see the port came back as soon as I removed the switch port mode access. Why? Because as soon as I took the switch port mode access, this command is no longer effective. So we should make this purely as a trunk port, not an access port. So I configured it earlier, okay? I am removing it as a switch port. Now purely this is a trunk port. Switch port, trunk, hello, VLAN. No, I want to add additional VLANs without overwriting this statement. You know what is the command? VLAN add 2 and 3. Okay. Show run. Now look at the interface configuration of SL0. See, it took all the VLANs. All the VLANs, right? Now I'm going to this end. You always don't forget to save memory, right mem, okay? So always now go to the SA01. We also connecting trunks, right? Configure the interface SA0 by 1. What is the command? You have to tell me. I'm configuring this is also trunk port. Switch port mode, trunk. Switch port, trunk, encapsulation. What's the command for the encapsulation?
Dot 1 Q.
Trunk.
Trunk encapsulation dot 1 Q.
Right, switch port, mode, trunk, and encapsulation. It's not taking the switch port. So you cannot configure this switch as a trunk because it's a layer 2 switch, right? So you cannot pass all the layer 2 traffic using a trunk on this switch. Let me see. Probably it will take by default trunk encapsulation dot 1 Q, okay? Configure T, let's hope for it. Interface SA0 by 1, switch port, trunk, allow, VLAN, add 2 to 4. No need to add because you don't have any existing VLANs to put this statement. If you have already an existing VLAN to the trunk and you want to add additional VLANs, you can put add command. It's a very interesting because it's in iOS, this is how the command runs, okay? Now do right now. How do I know the VLANs are added to the trunk? There is an interesting command, show interface trunk. You see that it took the encapsulation to by default. Good thing for us. And it's also considering VLAN 1 as still native. 2, 3, 4 are added to the trunk. Very, very nice. Okay? So IP interface B. You will find that VLAN 2, 3 and 4 are still layer 2 VLANs. But they are still forwarding the traffic to the which VLAN 2, 3 and 4. So we have one more switch to add the trunk. This trunk and this trunk. And once the VLANs reach to this database, you can put them on access. There you configure ports as access because this reaches the access port. And we will try to ping from PC to the layer 3 IP address on the VLAN interface. Then we should able to see whether we are able to successfully configure our VLANs or not. You see how we are distributing the traffic? So this distribution from here you have to trunk all this layer, all this switches trunk. But for end access switches, you only configure one uplink trunk. Now let's go here, find the switch ports here. SA0 by 5, SA0 by 1. Let's go to SA0 by 5. What we are going to do this also we are configuring trunk. Configure T, SA0 by 5, interface SA0 by 5, switch port, trunk, switch port mode, trunk, switch port, trunk, allowed, VLAN 2 to 4. Right? Show IP interface 3. Show interface trunk. You see that? VLAN 50 is also. So here the spanning tree is blocking them. It's not forwarding to the port 5. Why? Configure the interface SA 0x5 no shut. It's still not forwarding, which is not good. So let me see why it is not forwarding. Show run interface. Spanning tree is blocking the loops here, okay? Let's see in the future it allows, okay? Vlans are allowed and active in the management domain, but spanning tree is the protocol that forwards the traffic to the switch port. Here, it should always forward. Here, the Vlans are not forwarding to SA0x5. In switch port, it is not forwarding. So what I'm going to do is configure the no spanning tree Vlan 2, 3, 4. Now show interface trunk. You see that? Now I am able to forward. Otherwise, the trunk will not be successfully established. Understand what I'm saying? That's why spanning tree is very critical when it comes to the configuration. There is also possibility of loop formation here, but no problem. We are not configuring all these loops interfaces, right? We are only configuring one link at a time. So forget about spanning tree now. It's too far. Enable. Now before we configure trunk link, what should we do? We should add Vlan 2, 3, 4, but we already added it. So which interface we are configuring as trunk? Interface SA0x1. Which port? Mode trunk. Any questions so far? Which port allowed? Which port trunk allowed? Vlan 2 to 4. Show interface trunk. Actually, we are going to write Vlans in spanning tree forward states are not found, right? Here again, Vlans are not being forward. Spanning tree is blocking them. Configure tree, no spanning tree, Vlan 2, 3, 4. Okay. Let's see again, so interface trunk. Now they are forwarding. So you always make sure the Vlans are forwarded. If they are not forwarded, there is no use of configuring trunk. Now Vlans are configured layer 3 from here, and we are just passing the traffic, not the layer 3 communication. Okay. Now let's configure each team with its IP address. Okay. What is the Vlan 2 IP address we have to configure here? What is the IP address we have to configure here? Red team, right? 10.10.23. 10.10.23. What's the IP address we give? We'll give 3 address, not 3, because .1 is gateway, right? .10.23. One is the gateway. This is again red team, right? Vlan 2 red team. 10.10.23.4. Because /25, /24 you can configure 250, 252, other 253 addresses, right? So there is no shortage of addresses. So let's test this guy first. We should ping gateway. Gateway we defined here. So only layer 2 ping will come here. The response will come back, but it's not doing layer 3 routing, okay? It's only forwarding layer 2 broadcast. It's only forwarding layer 2 broadcast. What is the IP that we should ping? 23.1. Let's give it some time to resolve. Because I have to go here and forward here and forward here, forward here. It's because timing out. So first thing we have to do is now troubleshooting. Let's give it some time. Let's go back here and let's see show IP interface, please. So VLAN 2 is what we are troubleshooting now, right? VLAN 13. It is up and up. Can we ping the gateway from the switch on the switch itself? We should be able to. We're able to ping it, right? Now we'll go to the distribution switch. Are we able to ping the layer address from here? We should be able to. I'll tell you why we are not able to ping from here. Yeah, we will not be able to ping from here because we don't have layer 3 routing configured, right? We only have layer 2 VLAN configured. You know why we are not able to ping from this PC? Right? This is a PC, right, which we had opened. Can you tell me why we are not able to ping from this PC? No, we are able to ping from this PC. It took some time to resolve. Troubleshoot the access port here. What is the port is connected to? SA0/19, right? Show run SA0/19, we configure switch for access VLAN. You see, from PC only I am able to ping. Why? Because the PC is in which VLAN? VLAN 2, right? Everybody able to follow it? How I am able to ping that guy? 10.23.1, I am able to ping that, right? How am I able to ping? Because only this PC can ping it. Why? Because it has exclusive access to the VLAN. Even switch cannot ping on its own. It is taking some time to resolve, but it can ping eventually. We just saw that, right? Now let's go to another red PC. We also gave this IP address, right? This is also able to ping, right? See? We are able to ping. And we are also able to ping. The reason it is very slow is there is so much broadcast storm that is spanning through loops here. So that we'll discuss in the later how to make converging of the network faster. Spanning tree will help us converge faster, avoiding loops, avoiding broadcast storm. If you put packet from here to here, the packet will go from here to here, and to all the ports. There will be a big broadcast storm. I will show that animation in a while. Now, what I'm trying to explain here is, let's go to the VLAN 4. The PC in the VLAN 4. Any questions so far? The VLAN 4 is blue team, right? Blue team, what is the subnet here? To avoid confusion, so we will do show VLAN here. Blue team is VLAN 4, right? VLAN 4 is blue team, so IP interface 3. What is VLAN 4 IP address? 2.1, 171.169. So this guy is blue team. Okay? So blue team will give a IP address. Any questions, Kishore? 172.168.2. Which address you should give, Kavya? Let's go for 3. 255.2. 172.168.2.1. Okay? That is the gateway. 172.168.2.1. Okay? It's pinging, right? Without any problem with pinging. Now, can I ping a ready team member from here? Ping 10 dot. Can you guess? Can you ping or not? Maybe we are, maybe we cannot.
We should.
Let's see. Can you ping? You cannot. Can you tell why? The network, is in the router, you probably might not be able to ping because all the networks are connected to the VLAN. Sorry, to the interfaces. But here, in the router, we configure networks on the interfaces, and router will learn the interfaces networks and propagate the packets between them. But in switch, we are configuring on the VLAN interface. And VLAN will not, this will not learn the network address from the VLAN.
Okay.
And it will not propagate between the VLANs. Only specific members who have exclusive access to this VLAN will only able to ping the packet that belongs to the VLAN. So
Harsha, one question. Then only then, like from switch 0 only we can ping to either VLAN 2, 4 and 3. So between the pieces we can't then.
See, you cannot ping layer 3 IP address from this switch. Can you ping layer 3 VLAN IP address from this switch? No. Why? Because we did not configure the layer 3 routing for the packets to reach to this switch. And even if you configure, this switch will not understand because this is layer 3 switch. The VLAN trunk information that is coming from those pieces is being forwarded via trunk, and the switch will tag and untag that information VLAN and drop here and again forward it here. So VLAN information is propagated in a layer 2 trunk. You understand? When it's a layer 2 trunk, it's a layer 2 trunk. And the response is coming back onto the VLAN. But
unless we have the routing tables built on each switches, we can't interconnect with all of them.
You don't need to configure routing tables on each switch. Okay? You don't need to configure routing table on each switch. The switch doesn't have a management IP address. The switch doesn't have management IP address. If you configure a management IP address for this switch and give it a designation and configure IP address network address, for example, configure T interface management. Can I configure a management interface here? Cannot configure a management interface. So just imagine VLAN 1 has a management interface. I configure IP address 23.23.4.1. Okay, I configured let us assume VLAN 1 is management address for this switch. If I configure EIGRP, configure T router, can I give that command? Cannot, because this is the layer 2. Just imagine this is a layer 3 router, like this guy. Can I configure EIGRP on it, router? Yes, I can. And add the management IP address into the network routing table, then what will happen? This management address can be exchanged with this routing table, right? And this routing table will be able to ping this management IP address from this switch to this switch. Now, if you want to have access to the individual VLANs and ping from this switch, how you can ping it? You can ping it. You can ping it by saying ping the destination VLAN to IP address. For example, 192.16.2.1. Source. What is the source? VLAN 1. Because VLAN 1 can only ping the remaining network address because it is redistributed in the EIGRP table. You understand? From VLAN 1 interface on this switch, you can ping the management IP address because it's layer 3 and layer 3 communication place. You understood, right? So this is where the switching gets complicated. This is a very, very good question you asked. The reason we cannot ping the layer 3 from the switch because it is a layer 2 device and it cannot respond to layer 3 IP pings. But the reason we can ping this layer 3 switch from this switch because they both can understand IP communication and we can configure a management interface here. Okay? Enable configure the interface. Do you have management interface here? You also don't have management interface, but I can create a loopback interface as a management interface. Okay? So I can configure a loopback interface here, level layer 3 and layer 3 here, and put a routing configured between them. They will exchange the routes. You want to do that? Let's do that. IP interface loopback, 34.IP address, 34.34.1. Okay, configure one loopback network, right? Configure the router EIGRP 10. IP routing not enabled. What does that mean? Routing not enabled. Let's see if it's EIGRP1. This is not taking for them. I need to globally enable the routing on this side. Let's see, configure the router. Yeah, the IP routing is not enabled on this multi-layer switch for some reason. For this, I need to find a way to configure routing on this guy. How do I do that? Okay. So, configure management interface on this and put it on the routing table, and we can ping each other and also the management address of the switch.
Okay.
By how? By source pinging from the management interface, not from the switch management domain. That is how you can ping each switch area. That's a really outstanding good question. That will help you understand the difference between switching and routing. You understood, right?
Yes.
So you guys can work on this. Do a lab tomorrow. Configure layer 3 VLAN from this guy. I'm going to save this and forward to configure layer 3 interface from this one. Okay?
Okay.
And trunk on this one, like 564. Configure this as 5 VLAN 56, and you have to add trunk on this link, right? Configure VLAN on this one also. Configure this as trunk. So you have a distant PCs connected to distant switches, to different access switches. You should be able to ping red team VLAN from this to this, or say some other color. Give green, give brown, give magenta. So green should be able to green should be able to ping green, configure in here. Magenta should be able to ping magenta. Now you should get another genuine question, how I can ping VLAN 4 to VLAN 3, VLAN 3 to VLAN 2. How I can ping inter VLAN. How? I have to come back again, configure routing between these VLANs. Inter VLAN routing. Understood? That's where the concept of inter VLAN routing comes to the picture. So let's go back to our slides. So we have a big picture of VLANs now. We have floor 1, floor 2, floor 3. So each floor we have say different teams. This is how we distribute our VLANs. Right? So the switch will put a full stop to broadcast domain. Sorry, the routers will put a full stop to broadcast domain. Switch is what? It forwards so many broadcast domains. Switch will forward so many broadcasts, but they all end at the router interface. The VLAN membership mode, we also discussed about VLAN 1, VLAN 2, VLAN 3, port-based memberships, right? How we assign each VLAN to each member. So basically, what they are sharing is MAC addresses of each host. And the switch will also do MAC address table. Switch will also build MAC address table. You see here. Control C, show IP art. If I do show IP art, you will see the MAC address table. Show MAC address table. You see? You can see different MAC addresses learned by on each port. For example, I will see this PC 172.168.2.3. Should I be able to ping that? I should be able to ping that PC. Or else I'll ping from here. Ping 172.168.2.3. I'm able to ping from the code because it has a layer 3 access to this interface, right? Now do show MAC address table. Which port it should give? If I put the show IP art. Let's see how the switch propagates the multicast. Art table, right? It will be address resolution protocol. And then see, show IP art in this packet. See, what is the MAC address for this address is associated. This is the MAC address it is associated. Okay? Show MAC address table. Which port that MAC address is coming from? Which port that MAC address is coming from? This trunk port, right? SA0x1. See? MAC address comes in. So if you go here and see what is the MAC address of this guy, what is the MAC address? Can you read it? See how switch is communicating to this host. Physical interface. Father, did you understand what I am showing here? How the switch is building the MAC address table and it's reaching it. You see what is this MAC address here? Let me paste the MAC address here. You can compare both. So switch is communicating to this PC with its MAC address, but not my IP address. But how it knows which IP address on MAC? When I ping this IP address, it resolved it into MAC address by using address resolution protocol. That's why I did ARP first. After from ARP, when I did ARP, and after from ARP table, I found the MAC address it resolved into. So this MAC address belongs to this PC. So see how switching mechanism working here. Any questions? So, Kavya, any questions regarding this slide? How the switch is regarding the MAC address table? Now see here, this is what I'm trying to explain here. On one access port, you can either configure red team, yellow team, or blue team. Imagine if a red team trying to join an access port that is already joined by yellow team. It cannot happen. But one access port, you can give access to multiple red teams. It's basically one VLAN. You can also connect a hub and connect that hub to so many PCs that belong to red team. Which will still able to learn multiple MAC addresses from one single port. That is the beauty of switch. That is the disadvantage you don't find in hub. You can connect a hub to the further to the access port. No problem. Connect multiple red PCs. I showed you how to give a VLAN a name. I also showed you how to verify the VLAN in the database. I also showed you how you configure the access port and also how to remove the command of access port if you decide later on to configure it as a trunk port. I have also showed you how to verify the VLAN database, also how to verify each port that is particularly assigned to a particular VLAN by using show VLAN ID, VLAN name, and you will find all the ports that are assigned to particular VLAN. For example, in our case, we have multiple VLANs assigned to multiple ports, right? So see, VLAN 4 is assigned to this port, VLAN to this, VLAN to this. manifold. You see? Beautiful. Data is beautiful. Always beautiful. Helps us to understand, helps our accounting work very easy. Makes us job easy. So, you also show how to verify the running interface configuration, the basic command. I also showed you how to verify the MAC address table. Any questions on that? I also explained you what's the significance of 802.1c protocol and how it helps in tagging the VLAN. So, switch at each end knows which VLAN belongs to which VLAN ID, how it tags. ISL is a legacy protocol. You no longer use that trunking, switch port trunk code enable, switch port trunk encapsulation .1q. When you say switch port trunk encapsulation .1q, you are by default running the trunk on 802.1q. Native VLANs. The native VLANs, whenever you configure it, whenever you get a hardware right from the box, you will find all untagged VLANs. So, for example, if I go to this guy, so VLAN. You want to tag it as take a fresh PC, take a fresh switch. If I do show VLAN, which VLAN you will find? Can someone tell me? If I do show VLAN, which VLAN you will find by default? VLAN 1, right? So, VLAN 1 is default. What will happen if I do? If I configure in the trunk with VLAN as native VLAN. You know what happens? .1q will forward all the traffic as it is without tagging the traffic with the VLAN name. That is very helpful when you have so many, which is by default configuration, and you want to pass all the traffic as it is. Native VLAN helps during the time, but it is not advisable to configure more than one native VLAN, and you cannot configure that. And also make sure if you configure VLAN 1 native on the switch, you should also make sure that VLAN 1 is native on other end also. You cannot configure native VLAN 2 here, native VLAN 300 and trunk it as a native VLAN. It will not accept that way. Both VLAN IDs should match. We are not talking about ISL encapsulation because it's a legacy, but .1q we should definitely do. I also showed you how we can verify the ISL trunking. VLANs is silently forwarding state are not true. If the VLANs are not forwarded here and if it's being brought right, then there is no way you can propagate the traffic or the MAC addresses or any information. You should always verify by using show interface trunk command and see whether the trunks are being populated with the VLANs. Otherwise, the trunk is just failed. Spanning tree is blocking. In later class, we will learn how spanning trees plays an important role in forwarding the trunking information. This is just a beautiful description, a beautiful presentation of how we configure on the packet tracer, right? For distribution and access. This is the representing again here. You see how access layer, there are multiple access ports all pointing to one VLAN. So we are going to do that lab. This is how we configure the phone. Remember, trunk allowed VLAN, you can, if there are 10 VLANs serially, you can use this notation. Like 9 to 18 if you have some VLANs. You can put 9-18. So all the VLANs will add. If you are adding new VLANs, make sure you are not overwriting the existing VLAN statement. So you should always use Cisco trunk allowed VLAN add with the new VLANs that you are about to add. If you don't use command add, it will overwrite the previous VLANs and the trunk will sometimes drop and network outage is a serious issue. You can also use show interface command to really see all the extra information like what trunking. So VLAN trunking protocol is something advanced. If you have 20 VLANs on the core and want to propagate them to the access, for example, every day you are adding one new VLAN on the core and you want all the below layer switches to dynamically update those VLANs into there. Remember how we added every switch we went and configured VLAN 1, VLAN 2, VLAN, not VLAN 1, because it's default. How we configure VLAN 2, VLAN 3, VLAN 4, manually on each switch. Imagine there are 300 VLANs here. It's a very cumbersome process to add each individual VLAN on each switch, right? So VTP, if you configure this as server and this as a client, it will automatically update its database as per the server. But we will discuss in the future. But before tomorrow, we are going to discuss about spanning tree and how it forms an important role in forwarding traffic and blocking unnecessary ports. And also, if the time permits, we will talk about VTP, which is VLAN trunking protocol. VLAN trunk protocol. Any questions on VLAN, please let me know. This is very important class. You have to do lab, otherwise it will be very difficult for me to proceed further to the spanning tree and VLAN trunking protocol. You should understand this concept. Okay guys, so tomorrow the class will be there only if you all confirm me that you finished the lab, because it will be difficult for you and me to proceed further.
Okay, Arjun.